with that, I bring you technical foundations for PMs. So this talk, we're gonna talk about software application architecture, like all the bits of code that you need to make a website or a mobile app. And that basically we're going to talk about the client side, so what appears on your screen, what the user sees. This is the buttons, the layout, the images, the text. We're going to talk about the server side. So what's going on behind the scenes. This is sometimes called the backend. How requests from the client are processed. You can think of this as all the logic, the calculations, the decisions. We're going to talk about databases, so where information is stored permanently. We're also going to talk a little bit about how these are all connected together with APIs, and touch lightly on the software development process, and other ways that you can get kind of more technical yourself. I say, I don't consider myself a technical person. I have kind of become more technical by teaching myself a little bit of code, by playing around with AI tools, by being a product leader, and I have run engineering teams as well. But I never took computer science. I haven't taken extensive coding courses. So this is really a kind of intro level to these sorts of concepts, to give you that kind of like really robust foundation that if you are talking to engineers or having these conversations, then you can talk to them in a sort of meaningful way. You can challenge them in a way that is helpful, and so on. And again, if you do have questions, I'll try and answer them. If you get too technical with your questions, though, I warn you that you will reach the limits of my knowledge. So with that, I'm just kind of going to dive into it. So this is basically the architecture for any web app, any application is going to have this sort of architecture. You might see, if you've just written a static web page, a kind of hello web page, you will just have the client side, right? You won't need the server side. You won't need the database. If you've been building something, maybe you've been vibe coding a prototype, you might have the client and the server without having the database, right? So you can kind of click through it, but it's not going to remember anything from session to session. So you can cut out sections of these stacks, of this stack kind of in particular cases, but they're usually sort of exceptional cases or, training cases. You almost always have these three elements. So if we dive into the front end, that kind of client, like what does the user see? Then there are sort of three main languages, or kind of three main kind of components to what creates the front end. Like what does you see on the page? The first one of those is HTML. So HTML is, you might have seen it, it looks a bit like this. So you see these tags. You have tags like the body tag. You'll also get your headings tags, H1, H2, H3, paragraphs. If you see those, those from laying out blog posts or something like that. Those are all HTML tags. In Notion, when you change your heading from an H1 to an H2, those are effectively HTML tags, right? The other main thing that HTML does is it sort of structures and formats the content on the web page. So if you look at this kind of diagram on the right hand side, you can see it's all kind of divided up into blocks. And if you look at a web page, you'll also notice like the blocks won't have the kind of the lines here, but if you should be able to see that effectively it is divided up into sections, and those sections are stacked, top to bottom, and that is how you determine where things appear on the page. And then within each of those sections, you can then do sort of like additional formatting, again by defining the level of heading and so on. So the HTML kind of will point to images. It will kind of create the links for things, and this kind of, if you have a document like this, you just create a empty document and stick in this kind of content and then save it with the .html file. So you can do that in a simple text edit on the Mac, something like that. Any web browser will be able to open it and see how that reads, how that displays as a web page. So that's kind of your HTML. The second type of component, so second out of three that you get on the client end, is CSS, cascading style sheets. So these control the look of the web pages. And you'll see that in a CSS, this is effectively a style sheet. You've got these different kind of tags here: theme browser, theme name. Inside this tag, so if you label one of your elements in HTML with these tags, it will then get all of these styling things. And you can see it's defining things like the font size, the font weight. So that's how bold the text is, height, margin, padding, box shadow, all these different things. Cascading style sheets, as the name implies, cascading, like they inherit, they kind of stack up. So if you could have one of these blocks of code just for the .theme tag there, and then you could have this one which is like more specific that has the theme browser .theme name, right? So a block with the .theme, like all these three, would still get the .theme name as well because it's got the .theme name in it, but it's going to get all of these ones as well. This is really powerful for kind of making things, scalable, kind of reusing styles, having consistency. It can also be a real pain when you have defined something, you define like the height here is 18, and when you look on the page, the height of the font is not 18, it is 24. And that is because it's getting overwritten by another block of code effectively. And then finding where that block of code is getting overwritten can be difficult. So just to kind of like highlight some of the issues there. Third thing you'll get on the front end then is JavaScript. So JavaScript adds interactivity and logic to the web pages. So if you have say like a very simple calculator that you can put a date into and it's going to give you the day of the week, something like this, you might get, or you get like a mortgage calculator where you put in the principal and you put in the length of the mortgage and the interest rate, and it tells you what your monthly repayments will be. These sorts of things will generally be written in JavaScript. So you can put light scripts in the browser and run those without having to kind of connect to a server. And that means it's just much faster because as soon as you make a request to the server, you've got to kind of ping the server, which is someone else's computer. Even if it's in the cloud, it is a computer somewhere. And you've got to wait for it to respond. And that is going to cause a slight delay. It might only be a few milliseconds, but it's going to be slower than if you just do it directly in the browser. The downside is obviously you're going to have to load all that code into the user's browsers before it will run. So it's going to make the web page heavier and slower to load. This code, when you actually look at it, you can see is a lot of it will be these functions. So you can see here, this is JavaScript. It says, hey, function. We've got one function here called map. We've got another one called map iterator. And you've then got a series of logic. So, and here you can say we've basically got a loop where you've got saying like, if blah, 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 for, blah, blah, blah. I'm not going to go into kind of explaining kind of the actual code here. But if you understand some of the basic logic operators you get, things like conditional, if this, do that, if Y, do something else. Or if you've got a loop which says like, hey, for the length of this array, if this array has 10 numbers in it, do this 10 times, once on each number. These kinds of functions you can do, you will see in lots of different programming languages. And JavaScript is just the one that is easiest and is the most commonly used is the one that's used in the front end. So that's the front end. When we go to the back end, you'll see is exactly the same picture I have on the left-hand side, because you could also have your back end being JavaScript. As I mentioned, like there are a bunch of other common languages that all look slightly different. Python, Java, Ruby, PHP, C Sharp, and some of these will have different names or different frameworks where they're effectively sort of if these are the languages, they are like dialects of a language. So you have something like TypeScript, then that is a dialect of one of these languages. So again, your server, what that is doing is it's processing information that's been taken from either the client or the databases, and it's kind of somehow processing that data and then sending it back to the client or back to the database. Right. So this is how you can, if someone makes an order, then they're going to click a button on the client side that says like, hey, buy me this thing. It's going to go through to the back end. The back end is then going to like push an order into the database, orders database saying like, hey, this order was made by this person. This is the time. This is what they want. And then you have a record of that order in your database that someone else can call. The server's also going to handle things like authentication and scaling. So if only certain users can do certain things, that will be handled by the server side generally. So like verifying what people can see. Also things like scaling. So how many requests can you process at one time? That will be handled by the server as well. Okay. So we move on to databases then. So we've done client side, we've done servers, databases. So databases is where all your information is stored. And the easiest way to think about this is as big spreadsheets, basically with a simple structure where you have an ID and then you have like a series of different fields. Each field is in a column and each row is then a different entry in the table. So and this is sort of like the persistent data then that can be stored from session to session, that can be passed from user to user, and so on. So here you can see we've got a table which has all our customers on. We've got a table which has our orders on. And so the customer table, I've only shown a couple of fields here. It might have first name, last name, address, line 1, address line 2, postcode. It might have a list of orders, all these sorts of things. And then you'll have another table which is like, okay, these are all the orders. That also kind of refers back to the customer ID. So these two tables, you could link these on the customer ID, but your order table might also include, well, what are the products they bought? What was the total amount they spent on that order, and so on. So yeah, these are essentially tables listing data. Each of the columns, as I say, defines, it's effectively called the schema. So the schema for the table is what kind of information is allowed in each of these columns. So your first name might be a text field or a text string. So it can only take in, it's looking for strings of characters, whereas your customer ID, that might have to be an integer, right? Your total spent, that might have to be a floating point number. So there can be different types of data that you can have stored in each of these. And that sort of allows you to kind of like make sure you're getting the right inputs into the database, that you can then process that data in known ways, and kind of means that you can, helps the application run. You also notice that each table has an index. So you've got a primary index that's usually the first column you see is your ID, kind of 1, 2, 3. That's usually just like numbered sequentially. And that is a unique record. So you'll only find one row with ID 1, one row with ID 2. And so it's called the primary key because it is unique and it allows you to find each of those rows in a unique way. That's then really important if you want to link those two together, because as you can see in the orders one, we can refer to a customer ID and say like, hey, look up the customer ID, number 1. We know the person who made this first order is Jesse, right? And we know where they live then and who that was and so on. So that's obviously like quite valuable. But splitting up the, you obviously have to split up the data every time. You only need to know Jess's name once, and if they make 10 orders, you don't need 10 records, each with their address in. You can just store that once and say like, yeah, it's the same person making that order. So databases are often queried with SQL, which you may well have seen, even if you don't consider yourself technical, right? It's this kind of language. Almost always starts with a select call where you say, hey, select these fields. So you're looking here at the column titles. From customers here would be this top table, so that's the name of the table. And then you can put in different kind of requirements about what is the data that you want to see out of that. So these kinds of SQL queries will kind of give you a subset of the data, and that might be a subset in terms of like a smaller number of columns, a smaller number of rows that match all of these criteria. But effectively, your server will be doing a similar sort of logic when you make requests from it and say, hey, I'm searching for tickets and I want to see all the Taylor Swift tickets. You're doing a search on a database which contains all of the events of all the artists, and you're just picking out the ones which match Taylor Swift as the artist. So we talked about databases, server, clients. How do all these things speak to each other? Via APIs. So APIs are application programming interfaces, which you don't need to know. It's just how different parts of the system speak to each other. And basically, you make a request, you get a response. So you ask something, you get a reply. Those requests, they're always made to a particular URL or address. So that is where, so you can see here in this box, I've actually used like one of these no-code tools to create this API request. And it's really clear just what you're doing, kind of splitting out. So you can see that there's a URL that I'm going to call. I've got a method. So there are half a dozen different methods, but the two most common by far are get and post. Get just means like give me data, and post means I want to update something. So if I'm going to add a record to a database, or if I'm going to update a row in a database, I'm going to use post. If I'm just going to get a kind of response, I don't want to change it at all, I'll use a get method. And then you can see there are some parameters here. So the parameters, you've got things like the key, that's my API code, or sorry, it's my credentials. So this means like I've got to include that so that the API knows who is making the request, and it knows that I'm allowed to make the request, which is also why I've kind of anonymized it slightly so that none of you can use my key. And then you've got, in this case, you've got a queue parameter, which is the location you're looking for. So this is a weather, as it says, a weather API. It gives you a weather forecast. When you say, hey, what's the weather in London? It will then return a response, which is what the weather is in London. What's the weather forecast for London? More typically, that's going to be all of these things are effectively going to be kind of smushed together into a single line of code or a single request. If you were going to make this request in terminal, so that's where you kind of like type into your computer in a text way, this would be the terminal command to make this API request. Okay. When you get your response, it's going to be almost always a JSON object. So JSON is just a way of showing data. It allows you to have different levels to it. So you can associate, what is the current weather? The current weather has these things. And you can see we could have, multiple different conditions for the current weather, for example. But you can see here, it's got just a lot of different fields, and they've all got, then a value associated with those fields. It's worthwhile kind of learning some of the response codes if you are using JSON at all, but also when you see a website, if something's going wrong. So if you try and in your browser access a website and you get an error code, you'll often see sort of these sorts of error codes, 200, 400, 404, 500, 503. The very simple way of understanding these, 200, everything is okay. Like all is good. 400s, all the different 400 ones, some are basically you have made a mistake. So you as the user have done something wrong. You're not authorized to see the page. You haven't made your request in the right format. You're not authorized to see it. All those sorts of things. And so the different codes then will kind of give you more clues about what's going wrong. The 500 codes, they are saying that the server you are calling has got a problem. So it's not running, or it's overloaded, or whatever it is. So 200, everything okay. 400, it's your problem. 500, it's my problem as the server. APIs. So API example here, just to kind of like make this clear how everything kind of like links together. On the client, you as a user, you're searching for products on Amazon, and you want to have a look for electronics that are between $100 and $500 and have a minimum of 4 stars. So you're going to select that in the filters on the search bar, and the web page is going to generate this API request, right? With, it's got the URL, it's got the parameters. It will figure out the authentication because you're on the Amazon webpage, and it's going to send it to the server. The server's then going to process that request and effectively convert it into a format where it can call the database for those products that match. And it might have to call like multiple different tables to kind of stitch it back together to give you the results that you want, right? So the database is then going to return the records that match that request to the server. And the server's then going to, as I say, kind of like maybe process that, maybe stitch it back together and return a JSON response to the client. And then the client page is basically going to update and show this response, this data in a human readable way. So, maybe it's got the titles of the products. It might have images, which will be like links to, static resources it can call on. But it's going to kind of like stitch these all together in the way the HTML, the CSS, the JavaScript kind of like tell it all kind of needs to sit together. Okay, so that was clients, servers, backends, databases, and API requests. I wanted to touch briefly on development environments, just kind of like get these clear. So generally, there's 3 levels to how software is built. So you've got your kind of local level. This is code running on an individual person's computer. And this is where the code is written. So you kind of like, you get a copy of the website, you put it on your machine, you run it on your machine, and you change the code, and you can see how it changes. If you're building something from scratch, it's going to start on your machine first. Once you've got it working on your machine, you're going to put it into a staging environment. So a staging environment is a copy of the website that is sort of available to like lots of people, but not everyone. So it might be available to all the developers or all of the company, internally. But it's connected up, it's using this sort of the as close a copy to the infrastructure that the real website is working on, so that you can test when you put your code there, it still works. So this is usually where you're doing a lot more testing, just checking that everything works as expected before you put it live. And then production, this is the website which users can interact with, has all the live data, and yeah, what people see. And this is important because I think, this local environment for me, I kind of understood staging production as a product manager, like fairly. I was like, yeah, it makes sense. Something that tripped me up for a long time is I was like, okay, local, I get it. That's on a developer's machine. I hear them talk about this all the time. Works on my machine. Great. If I want to write code, how do I get it to work on my machine? Like, how does that work? Where do I type the code? I can write some JavaScript, but where do I type the JavaScript? Because I don't put it in like a Google Doc. It doesn't run. What do I do? And this is where you get to IDEs. So an IDE is an integrated development environment. This is sort of where you write your code as a developer. And you might be using here something like VS Code, GitHub Copilot, which I think this is a screenshot of, Cursor, Windsurf, some of the more modern, or not more modern, but AI powered ones. But you can see here what you've got are so there we go. Yeah. The code itself. So you can see you've got a window here. You can actually see some of the code. So this will be JavaScript or whatever it is that we are, or TypeScript from the looks of it. So that's the actual code that you'll be editing as a developer. You can see actually on this screenshot, you can't see the file structure, but you can generally see a kind of side panel where you can then see all the different files that are in the system, because you'll have code in multiple different files and kind of break it into files to make it easier to structure and know what's what. You'll probably get this connected to GitHub so that you've got version control. So you can see on the left-hand side, it's sort of like talking about, actually, sorry, that's talking about agent stuff, but you can see there are kind of like, there's a little branching out icon up here. That is going to help you kind of like do your version control. You might also get logs and console outputs. So as you're testing your code, if things are breaking, are you getting any kind of like error messages telling you what's going wrong? And increasingly, you're going to get this kind of like this right-hand panel here where you've got an AI assistant that's helping you write code, that's answering questions about what the code does, and kind of get, where you can do a bit of back and forth with it, if not ask it to write the code or some of the code for you. I think this is, I kind of point that out because in the last 12 months, as vibe coding, AI prototyping tools have emerged, this has just become an insanely fast way to learn how to code and how to be more technical. So if you look at something like Lovable, then what you'll see is you've got quite a friendly layout, basically, where you're like, yeah, this is great. I've got a chat interface on the left-hand side, which looks a bit like ChatGPT. Nothing scary about that. And then I see a preview of the app I'm building. Nothing scary about that. That does not feel very technical at all, right? I tell it what to build and it goes and builds it. Great. There's actually a toggle on Lovable, though, where you, instead of seeing the preview of the website, you can see the code behind it. And when you see that, you'll then see that's the file structure in the middle, and then you've got the code for any of the files that you click on, and you can see the actual code that it's generated. Okay, great. So that is going to allow you to then see the underlying code that's building your website. Great. I mean, even if you start just toggling on that code and then having a look at the different files in there, you'll be able to see some of these are .css files, some of these are HTML files, some of these are kind of like JavaScript or other kinds of types of files. And you'll be able to understand what these files are doing. And the folder structure will generally be in a somewhat kind of like human readable manner. So you might see a client folder or a server folder. You might see a CSS folder, things like this. So even with what we've covered in this webinar, if you build something in a one of these AI tools, you'll be able to start understanding the file structure behind it and what each of these files are doing. From Lovable, it's quite a small step to a tool like Replit. Replit is essentially just another AI prototyping tool. It's got a little bit more functionality on it. It's a little bit, a few more windows. You can actually get your error logs a little bit easier. It's, in some ways more fully featured than Lovable. In some ways, that just adds to complexity. So if you were going to choose one of these for the first time, I'd suggest Lovable. If you wanted a bit more control of what you were doing, I'd choose Replit. But you can see here, you've got your, the same elements, right? You've got your preview, you've got your code blocks, you can see you've got your assistant. But from Replit, it's really a very short step to Cursor, which is a proper IDE. This is the kind of like developers write their code here. So I kind of show this just to show that the steps between something that's very kind of PM friendly, non-technical friendly to something that is like actually where engineers write their code is not as far as you think. And if you start playing around with these tools, you will just get a lot more technical very, very quickly, because the feedback cycle is so quick between asking it to change things in the prompts, in natural language, seeing the page update, the preview, and seeing what code it's generated. So that's kind of all I'm going to cover in this session. But just to kind of like finish up, like my one recommendation would be like if you do want to get more technical, of course you can go and take a coding course, but coding courses are usually kind of on a particular language, on a particular, teaching you a particular skill set. I would super recommend the our Build with AI course, which then teaches you kind of this progression from AI prototyping into actually coding with AI tools. Because in 4 weeks, what we do is we go and build a bunch of APIs. We go and kind of build a bunch of AI prototypes. We go and actually write stuff in Cursor, and that's great because you get to build some stuff. But actually, what I hear consistently from people who come on the course is that for them, it just kind of hugely levels them up in terms of how confident they feel about talking about technical concepts and talking about those technical concepts with engineers. We do also have all of the content in this webinar and kind of like a few more details in article format. We've also got like a cheat sheet of kind of common technical terms, common sort of HTML tags, CSS tags, all those sorts of things for paying members on the website as well.